everyone, today I want to show you how to create that mountain scene in geometry nodes. You can add or subtract some mountains, and you can change the position of your mountains, for example like that, and you can rotate them. You can of course change the height of your mountains. You can add some more details, and of course it's a really large scale as you can see, so that you don't get any problems with some proportions later on if you add your own models to it. You can of course add some trees, and you will be able to define the snow density, the amount of snow in your shader material. So if you want to know how to create that, just watch that video. We will start with our default cube, activate it, and go to the geometry nodes panel and create a new geometry nodes setup. We disconnect the group output from the group input. By the way, by pressing N, you can activate that panel on the side, also on the viewport. And we will start with a grid. And because we want to make things in real world measurements, because I think that's always helpful, especially when you want to combine your 3D mesh with other models, you always have problems if they have different proportions. So I like to use real world measurements, or almost real world like measurements, and we will make that grid for the start maybe 800 with 800 meters, and we need some resolution, not too low. For the start we will go with 500, and let's connect that. And to get some more details later on, we have to add a subdivision surface. At the moment we can leave it at 0. Later on we can turn it to 2. If your computer can handle it, maybe to 3. The higher the level of subdivision surface, the more details you get into your mountains, and the cooler and the more realistic it will look. So now we will need a set position node. Later on we will put our distortion right into the position channel, and we will need a set shade smooth node. And of course we want to give it some material. Type in set material. At the moment we can leave that empty. We will fill in the material later on. So now that's our base grid, our landscape. Select everything and press Ctrl J to make a frame around it. And when you click on node, you can type in a name. I will name it landscape. Now it's time to make the distortion, the noise displacement, and therefore we will need a noise texture node. We will need some RGB curves. We will need a math node that we set to multiply. And we will need a combine XYZ node, because we only want to affect the Z channel of our layer, of our grid. And now to get it all into our set position node, we will need a vector math node and a position node. The position node will give us each point of our grid and will deform it and will be affected by our noise detector. By our noise texture. Sorry. If we don't plug in the position node, the whole area will be distorted by our noise texture, and we don't want that. We want every point to be distorted. So let's plug all the nodes together. We will need the color node, and we plug that into the color node of the RGB curves. And maybe we can set it to 4D to get some variations to it. And now we need a very large scale, 0.01. We want many details in our surface. The roughness you can leave at 0.5, and the distortion, maybe we can give 0.5, only a little bit of distortion. The color output goes into the value, and that one later on will define the height of our mountains. So now we can already type in 30. We can adjust that later. And the multiply goes into the Z channel, and that one goes into the lower input, and the position into the upper input. And we leave that at add. And all this goes right into the, to move a little bit backwards. That goes into the position channel. So now we got our already some distortion on our grid. Now it's time to add some mountains. As you can see here, you can define the height of our grid and later on the height of our mountains, and we will make a new frame around that. Hit Control J, and we will rename that to noise displacement. So now how do we get some mountains in that grid? For that we will use a proximity noise effector object. It's a similar approach like you maybe have seen in my modular island tutorial. I will put a link in one of these info cards and into the description down below. Now, first of all, we will need some noise, proximity effector object, and therefore we will go with an icosphere. You can choose any object you want. You can also choose a cube. When you choose a cube, you will get some very flat mountains, like I don't know the English right expression. It's a table mountain. In German, it's a table mountain, like one of these from South Africa, typical one. But I will go with first an icosphere, and with an icosphere we get some typical normal mountain shape, not something flat. And also we have some large scale model. We will turn up the radius. I think the subdivisions we can leave. I don't think at the moment they have any influence or big influence to our mesh. We can try that later on. And because we want to move our mountains and we want to be flexible concerning the position, we will need or add a transform node. Connect that. And now that we see what's going on, we will first add a join geometry node. Now plug in the transform node into, where is it? Our join geometry node, and there you can see we have our icosphere. Maybe we can turn up a little bit bigger, maybe to 100. Yes, something like that. And now we can create our proximity object. Therefore, we type in geometry. Where is it? Geometry proximity. There it is. And why is it red? Disconnect that. We will connect it later. And now we will need a vector math node. It does not work because the geometry proximity node cannot go just into the joint geometry. There have to be some other nodes before. And the vector math node we set to distance because we want to measure the distance between our proximity object and our grid. Set it to distance. And because we want to have we want to measure all the points from our proximity object and our grid, we need the position of every vertex of our proximity object. And again, we need a position node. Plug the position node into the upper one and the geometry proximity in the lower one. And you can leave that at faces because we want to measure the distance between the faces. And so now how do we get the proximity object into our noise displacement? I made some experiments, and the best way that it worked out for me is to use a map range object. We plug that right between the multiply node and the combine x, y, z node. We can leave that at float and linear. Deactivate clamp because we don't want to cut off the height of our plane at a certain value. So you can deactivate clamp. And now we plug in the distance output into from max. And as you can see, our proximity object does what it does. It makes some distortion on our plane, but of course much too high, and that's because our proximity object is intersecting with our grid, and everything goes up into the infinite area. And to avoid that, we have to we connect it again with our joint geometry to explain it a little bit better. So I will move it up, and as you can see, when the tip of the icosphere arrives at the bottom, the area begins to rise. The problem now is that our sphere touches the ground at the bottom here, but the rest of our sphere is very far away from our grid. So when we touch with these points or these faces our ground, the bottom of our sphere will be under our grid, and everything under the grid will be rise into infinity. So we can change that with scaling our sphere, and we will scale it in the z-axis and make it very thin. So now when we arrive with the bottom point at the surface of our grid, the outer parts of our icosphere also have some proximity touch, I will say, with our grid, and will affect, hopefully it does, will affect the mountains that we need. Go down, 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 down. And as we can see now, a brighter area now is influenced by our icosphere. And as soon as our midpoint goes right under the surface of our grid, the mountain rises into the infinite. So now we have already something like a mountain. At the moment it's very round, and we can change that by just deforming our proximity object. So for example, we can type in 1.4 to make it a little bit brighter in the x-axis, and also we can deform the y-axis, maybe something like that. And we also can rotate it. For example, something like that. That's a little bit too high. You see it's a very sensitive value. So something like that, and the y-axis maybe. Again, we have to change the z value. So something like that. That looks pretty much like a mountain. So now we can turn off our connection to the geometry node, and as you can see, we got some pretty cool looking mountain. And now when you, where is our subdivision surface? Here it is. Now when you increase our level of subdivision surface, you will see that we get some pretty nice details in our mountain, and the details will influence how we see some objects, because the more detailed there are, the bigger it looks to us. So when we erase all the details, it could be also a mountain or a small hill, maybe tall as a man or something like that. But as we increase the subdivision surface, it already begins to look like a big mountain. You can increase that impression by moving your camera point just to the bottom, so it even looks more like a mountain, but that's something we can adjust at the end. For now, I will turn it to 0. And now here comes the fun part. We can now adjust the height of our mountains just with that value. And we can also give it some randomness with the RGB curves. You can play with that. That looks pretty cool. So now you have the choice. You can add some join geometry right between the transform node and the geometry proximity node. And now you can add some more mountains, and you can just move them around like that. You can rotate them maybe around the x-axis. With the z value, you have a certain control about the height of your mountain. No, it was 10, not 100, sorry. We'll play with 9. No, 9 is too high. Maybe 11, 10.5, 10.7. You see it's very sensitive. Something like that. That looks pretty cool. Pretty realistic. So now the problem, no, that's not a problem. You can change the overall height with just one value. If you want to use several height values to several mountains, you have to copy that whole thing, create a new Z position node, and plug that whole expression into the next Z position node, and then you have control about several height ranges here, and everything that's within that node tree you can control with the one height, and the other one just controlled with the other height. If you want to, if you not want to rely on only the Z position of the very sensitive Z position of the transform node. So now we got our mountains. You can play around. You can use some cubes or some other primitives geometry node offers. But I think for the sake of the tutorial, we can go with that shape. And now we can add some material. Of course, I've created already a material, and for that I will, how did I call it? I think I called it Snow Mountain. So let's have a quick look at it. By the way, I've created, where is, let's open a shader viewport. Snow Mountain, there it is. I use that temporarily material view, because if I put my material on my whole geometry nodes scene, the material will be just go over every item, every primitive I use in the geometry node setup, and I don't want that. That's because I use that temporarily material layer. I place that somewhere down below here. It's just for the sake of showing you the material. So I don't will get very deep into explaining the materials. You can see I have created one material on the in the upper part, and one material, that's the stone material, in the lower part. I did not create the material, I did not create the stone material by myself. The ice material I created by myself. For the stone material, I used the Blender Kit add-on. I can only recommend. I will put a download link in the description. And with the Blender Kit add-on, we have a variety of materials. The materials are all for free. And I think I just typed in rock, and you get a bunch of cool rock materials. You can choose between many categories. We have some search filters, and I strongly recommend to use at deformed geometry nodes models to use procedural texture, not texture-based, procedural. And now you can see we got some cool procedural noise stone textures. I can't remember which one I chose. I have maybe that one, I think it was. No, you can choose whatever you want. The point is that I connected these two materials, that one below and that one here up, with, wait a minute, I will just increase my subdivision surface to get a better view on the ice shader. So now we have more details. Now I plugged a mixed shader node right between my two materials. The stone material goes into the lower one and the ice shader goes into the upper one. And then I created a geometry node with a normal output, a normal node, and that one, the normal node goes, the dot output goes into the color ramp. So what does that node do? It gives us the direction of every point or face of every face of our deformed mesh, and we get to know where the vector is too steep, that there can't be any snow, and at these faces there will be the stone material, and at the points where it's not too steep there will be snow, because normally snow comes from the sky, and where it's too steep there can't be any snow normally, and at some points where it is flat you can find snow. So it's a very natural looking texture, and we can define the density or the amount of snow by scaling or moving our color ramp. So now we got our mountain material. We can close our shader and again make subdivision 0 so that we can work with our geometry nodes. And now maybe we can group that. And now it's time for some trees. Again, I've also renamed that for rock to trees. I did not create the trees by myself. I downloaded also from Blender Kit some trees. Let me just show you. Trees. There we got some trees. I have now the paid version of geometry of Blender Kit. I think that's right at the moment €6 per month. But also in the free version there are many trees which are free. You can search them free first. Be aware of that your trees don't have many polygons, because we need much of them in that scene now. I can just show you by activating it. We will jump into one of our trees, and there it is. Now I activated the bound view, but I can tell you that all the trees, they are all the leaves, they are not single vertices. It's with image, texture, and some alpha channel. So the amount of vertices is not too high at one of these trees. Also, it looks very detailed. Just be aware of that when you add your own models or your own vegetation assets. Now let's deactivate that collection here. And now how do we get the trees into our scene? So we will need a distribute points on faces node, and we will connect that with the Z position output of our landscape. Of course, we will need an instance on points node. Connect that with points. And now just drag and drop your collection where you have your vegetation assets in just into the geometry nodes panel, and plug in that one into instance. If you use a collection, be aware of that you activate separate children, reset children, and activate pick instances. Otherwise, you will get some weird results that can even crash your computer. Now, before we connect the our instances with our join geometry node, be aware of that you turn on the density very low, because you always you never know how, if something is wrong, and that will crash your computer. So I will start with 0.1, And let's see what happens when we plug in that into our joint geometry node. And as we can see, we got many trees. We got them spread all over the mountains. And of course, we don't want that. So we have to create something that will influence the position of our trees. So to do that, we will create something like a vegetation border. But first of all, we will group that, hit Ctrl J, and rename that to trees. And now we want some vegetation border so that we control where our trees begin to grow. And to create that, we will need a value node. That value node will be something like the set position of an imaginative area where the vegetation begins to grow. We can leave that at 0 at the moment. We will need a position node. We will need a separate X, Y, Z node. I will shortly explain how to combine all these values. We will need a math node that we set to greater than. I think I've already used that node composition in my lonely tutorial island. Again, we will need a math node, which we set to subtract, activate clamp on both. And we will need my favorite node, a map range node. And we also leave clamp activated. So now plug in the position node, because we need the position of each vertex of each instance of our tree instances, and we plug in the value node, our area of our plane that we can see, into the math node and the Z channel, because we only want to the information from the Z position of our plane, and we will plug that into the upper value, and the subtract node we will plug into the value, and now everything goes into the, just moves it a little bit to the left, will go into the selection channel of our instance on points, because we select which of our instances should be shown. Now it has deleted every single tree. That's because our plane is right now at the 0 point. So it deletes everything that's greater than the 0 point. To change that, we just have to increase our 0 point. Also, let us change the scale of our trees. Right at the moment, the trees are a little bit too big, I think. So our mountain looks very small compared to the trees. And to change the tree size, we will add a random value. Plug that. First of all, we are going to type in 0.1, and the maximum size of our trees maybe 0.4, and we plug that into our scale. And that looks a little bit more realistic. So now let's get back to our vegetation border. we now have control about the vegetation, the trees. Of course, you can add more vegetation, just copy and paste that and that whole node composition and plug the output into the join geometry. But of course, it looks still very unnatural. We don't have that exact border in real nature. So we need to give it some random value. And to make that border more randomly, we need a random value node, and we plug that right in between our non-existing plane and between the math node. And as you can see, we now have some pretty cool natural looking distortion. And as we increase our random value, it's getting more dense. And the lower it gets, the more widespread it is. And when we now increase the height of our vegetation border, you can see it starts looking more unnatural. So we can group that and rename that vegetation border. And the only thing that's left right now is, in my opinion, the forest is too uniform still. Also, it's scattered randomly. So of course, first of all, we have to give each tree a random rotation, because at the moment they are all looking into the right direction. Also, again, use a random value, set this to a vector, and we only want to influence the Z rotation. So type in 0, 0, and I was told when I type in tau multiplied with 2, that's 2 times, no, only tau, that is p multiplied with 2, and that gives us the maximum rotation of our trees. So it doesn't matter if I type in any number that's higher than 6.2 when I understand that right, and we plug that into our random rotation, and we got some random rotation of our trees. The last thing I want to add now is the clumpiness, the noise of our trees, and therefore we create a noise texture. When you have watched my my polar landscape tutorial, I used that technique there too. I use some noise texture to delete some of the trees, and we need a color ramp. We plug in the factor into the factor and the color output into the selection. And now we should have some better control of the distribution of our trees. So it looks, you can control now with the scale of your noise texture, the clumpiness, the dense of your random distribution. So maybe if I type in 0.01, we have no 0.01. You can create something like that. That could look very natural too. Maybe you can combine that with other vegetation. So you can show in that empty area some grass vegetation or something like that. And I think that's all. To get to get an effect like you have seen in the intro. I've only added a cube with some principled volume texture in it, and when you do that and activate the subdivision surface, you get some pretty cool looking and easy to change mountain landscape that you can use in background or however you want. Hope you learned something in my tutorial. Give me a like if you liked it, and maybe even subscribe. That's up to you. So maybe I see you at my next tutorial. Bye.